Hello students and welcome to my channel Maths Hub by Dr. Tanya Bose. So before this I have published 5 videos on the topic of lattice, and in the last video I talked about upper bounds and lower bounds. So in this video I will be focusing about the least upper bound and the greatest lower bounds. So now, as the name suggests, least upper bound. So what is the meaning of least upper bound? So least upper bound means from the elements of the upper bound, we need to select the least out of them, right? So what's the definition? A least upper bound is also known as the LUB, L dot U dot B. So any element x is called the LUB of the subset A if x is an upper bound that is less than every other upper bound of A. So as I told you in my previous video also, that whenever we are working with upper bounds and lower bounds, we are not concerned with the entire POSET, but we are only concerned about a particular subset in that POSET. So once we get the collection of all the upper bounds, the least upper bound will be the smallest among all those upper bounds, right? So how do we note a least upper bound? We also call it as a supremum of A. So for whichever subset we are calculating the least upper bound, it is called the supremum for that subset A. So we also denote it as supremum of A is LUB of A. And the notation, so if suppose the set A contains the two elements, let it be A and B. So how do we denote that we have to calculate the least upper bound? It is denoted by the symbol this, and this is called the join symbol, right? So a supremum or the least upper bound is denoted by the join symbol. So if we have to calculate the supremum or the least upper bound between these two elements, we denote a V symbol here. So it is called the join. So we read it as A join B. So this is the definition of least upper bound. So now let's move on to the definition of greatest lower bound. So again, from the word greatest lower bound, it means that from the lower bound set, we have to choose the greatest among all the lower bounds. So let's come to the formal definition of a greatest lower bound. A greatest lower bound is also denoted by the symbol GLB. So it is normally called by the name GLB. So any element y is called the greatest lower bound of the subset A if y is a lower bound of that subset A that is greater than every other lower bound of A. So from the lower bound set, whichever lower bound is the greatest in rank in your POSET, that will be declared as the greatest lower bound. So a greatest lower bound is also called the infimum of A. So you should be aware of these terms. So greatest lower bound is also called the infimum of A. And how do we denote the greatest lower bound? We call it as inf A is equal to GLB. So again, suppose that A contains the two elements C and D, and I have to calculate the greatest lower bound between these two elements. So we denote it by this symbol, and this symbol is called the meet symbol, right? So we will read it as C meet D. So C meet D means we need to calculate the greatest lower bound, right? So this is the symbol for least upper bound, and this is the symbol for greatest lower bound, right? So let us clear these definitions with the help of some exercises, right? So let's go to the first exercise, and the first example shows that the case diagram is given to us, the POSET is given to us, and we are given some subsets also. So subset A is C comma D, subset B is A comma B, subset C is E comma F. And we need to calculate the upper bounds, the lower bounds, the least upper bound, and the greatest lower bound. So we'll do it one by one. So let us try for the first set, that is set A, which is containing C and D. So now let us talk about the upper bounds of this set. So to calculate the upper bounds of this set, what are the upper bounds of C? This is the element C. So you can clearly see that the upper bounds of C are C and E. Now who are the upper bounds of the element D? the upper bounds of the element D. So D is here. So the upper bounds of D are D, E and F. Right? So when I have to calculate the upper bounds of set A, I have to select the common elements, right? So which elements are common? The only element that is common is E, right? So that means for upper bounds, we will get the answer as E for set A. Now let's talk about the lower bounds of C. The lower bounds of C, let me change the color of the pen so that you don't get confused. So the lower bounds of C are, so which elements are lying below than C? It is C and A. And what are the lower bounds of the element B? The elements are D, A and B. So who are the lower bounds of set A? So we have to select the common elements and the common element is E. So that means in the lower bound we will get the element E. Right? Now, once we get the upper bounds and the lower bounds, we need to select the least upper bound and the greatest lower bound. Now, since the set is only containing one singleton element, so the least upper bound is the same as the upper bound. So we will get the least upper bound as E. Suppose there were two elements, then we will select the least among them. Similarly, in the lower bound set, we are only getting one element, that is A. So that element itself will be acting as the greatest lower bound. Right? So now let's talk about the second set, that is set B. So I'm just rubbing these elements from here. Okay. So let's talk about the first set, that is set B. And in set B, let's talk about now set B. So set B is containing A and B now. So who are the upper bounds of element A? The upper bounds are A, C, D, E and F. Who are the upper bounds of the element B? Upper bounds are B, D, E and F. Right? So who are the upper bounds of set B? Which elements are common in both? One element is D, the other element is E, the third element is F. So that means when we will talk about set B, the upper bounds are D, E and F. So you can just fill it over here. Let's talk about the lower bounds. The lower bounds of element A. The lower bounds of element A is nothing. It is just A itself. Who are the lower bounds of B? The lower bounds of B is B itself. Right? So who are the lower bounds of set B? There is nothing common, so it is an empty set. Right? Now let us come to the least upper bound and the greatest lower bound. So for set B, the least upper bound, the upper bounds are D, E and F. D, E and F. I have to select the least among them. So the least upper bound will become, right? I hope this is making it clear. We have three elements. So the least among them is D. And since in the lower bound set there is nothing, so the greatest lower bound will be an empty set. Right? Okay. So now let's talk about the last set, that is set C. Just let me remove all these elements. Okay. So now let's talk about the upper bounds of, we are talking about set C now. So upper bounds of E. Who are the upper bounds of E? It is only the element E. Now who are the upper bounds of F? It is the only element F. So who are the upper bounds of set C? Nothing is common. So it is an empty set, right? That means in the upper bounds, we will get an empty set. Now let's talk about the lower bounds of the element E. Now who are the lower bounds of E? So the lower bounds are E, it is C, it is D, it is A, and it is B. Now, who are the lower bounds of F? The lower bounds of F are F, then we have D, then we have A, and then we have B, right? So now, who are the lower bounds of set C? The lower bounds of set C are, who are the common elements? D is common, A is common, and B is common, right? So now let's talk about the least upper bound. Upper bound set is containing nothing. It is an empty set. So the least upper bound will be 5. And what is the greatest lower bound? In the lower bound, we have 3 elements, D, A, and B. So the greatest among them is D. So in the greatest lower bound, we will get the element D, right? So I hope this exercise makes these definitions very clear to you. Let's try one more example. So in the next exercise, this is the POSET given to us, and we have to fill the same columns. We are given set A and we are given set B. So I'll explain you for set A and you can try set B on your own, right? So let us talk about the upper bounds of the element A. We are talking about the subset A. So let's choose first the element A. So the upper bounds of A are A, B, C, D, E, as well as F. Who are the upper bounds of the element C? The upper bounds of C are C, D, E, and F. And who are the upper bounds of the element F? It is F and E, right? So now let us choose who are the upper bounds of set A. So the common elements are F and E. So we have 2 elements, that is E and F, right? Now let's talk about the lower bounds. Now who are the lower bounds of element A? A itself, there is nothing lower than A, so it is only A. Now who are the lower bounds of C? The lower bounds of C are C and A. Who are the lower bounds of the element F? The elements are F, it is C, and it is A. So now who are the lower bounds of set A then? Which element is common? Element A is common to all, right? So that means when we are talking about set A, the upper bounds are E and F, the lower bounds are set A, singleton set A. Now let's talk about the least upper bound. Now in upper bounds we have 2 elements, E and F. So which is the least among them? It is F, right? And then the greatest lower bound, since it contains the upper bound set is containing only 1 element, so that element itself will serve as the greatest lower bound, right? So you can try set B on your own, right? And you can see the answers also displayed here. So I'll also tell you a shortcut to calculate the greatest lower bound and the least upper bound, right? Now I'll tell you the shortcut for set B now, right? Without calculating the upper bounds and the lower bounds. Now set B contains the 2 elements, that is C and D. So let's locate C and D. So this is C and this is D. So whenever you have to calculate the least upper bound, you will go in the upward direction and you will find the first point of contact, right? The first point of contact in the upward direction. So when you move from C to D, which is the first point of contact, both are meeting at point D. So the least upper bound will become, for set B, the least upper bound will become, right? And similarly, when we are calculating the greatest lower bound, we have to find out the first point of contact in the downward direction. So when you join D and C, which is the first point of contact in the downward direction, it is C, right? So the greatest lower bound will become. So this is the shortcut. So without calculating the upper bounds and lower bounds, we can directly calculate the least upper bound and the greatest lower bound. So again, I'm repeating, whenever we have to calculate the upper bound, go in the upper direction and select the first point of contact. And when we are calculating the greatest lower bound, go in the downward direction and calculate the first point of contact. Right? Both the methods, if you calculate the upper bounds and lower bounds and then you select the least and the greatest lower bound, you'll get the same answer. If you do not calculate the upper bounds and the lower bounds and you directly calculate the least upper bound and greatest lower bound by this method, then also it will give you the same answer. Right? So you can try set B with the long method and you can check your answers. And similarly, you can try the next exercise. So this is the POSET given to us and you are given two sets, set A and set B. And you need to calculate all the four parameters, that is the upper bounds, the lower bounds, the least upper bound and the greatest lower bound. Right? The answers are already given there. So you can check your answers without checking them right now. Right? And let's come to the next exercise. This is one more exercise given to you, so you can try this also. And please let me know in the comment section if you have any doubts. We can discuss that again. Similarly, you can try this exercise. The POSET contains the elements 1 to 8. The case diagram is given to you. And for the subset B, that is containing 3, 4 and 5, you need to calculate the upper bounds and the lower bounds. Right? So the answers are again given. Now, one very important remark. Now, since we haven't moved to the definition of lattice, so this is a very important table that you should be remembering when we will be calculating the lattice topics, right? So whenever the relation is a subset relation, what are the meanings of LUB and GLB? If it is a subset relation, so everything we are working on a POSET. So the POSET is S along with the relation R, right? So if this relation is a subset relation, then LUB, that means the least upper bound, means to calculate the union between the two sets, right? Similarly, if we have to calculate the GLB, GLB means to calculate the intersection between the two. Now the second one says that if the relation is a divisor relation, so if it is a divisor, for example, when I did the second video on Hayes diagrams, we did many examples on divisor, right? So if it is a divisor, then what is the meaning of LUB? The least upper bound means to calculate the LCM between the two elements. And similarly, GLB means to calculate the HCF between the two elements. And if this relation is a less than equal to symbol, then the greater element is the LUB and the smaller element is the GLB, right? So you can remember it like this, L and U. Whenever it is a subset relation, U for union and L for LCM, right? So the rest is the opposite. For GLB, it will be intersection and HCF, right? So let's see on what exercise we can apply this. Now suppose the question is find the GLB and the LUB of the sets 3, 9 and 12 and the subset 1, 2, 4, 5, 10 if they exist in the POSET Z plus along with the divisor operator, right? So in the divisor operator, as told to you, if you have to calculate the LUB, LUB means to calculate the LCM and GLB means to calculate the HCF, right? So the first subset is 3, 9 and 12. So when I have to calculate the LUB of this subset, LUB of this subset means I have to calculate the LCM of 3, 9 and 12. And what is the LCM of 3, 9 and 12? It is 36, right? Similarly, if I have to calculate the GLB of 3, 9 and 12, that means I need to calculate the HCF of 3, 9 and 12. And what is the highest common factor? It is 3. Right? Similarly, let's calculate for the second subset. If I have to calculate the LUB of 1, 2, 4, 5 and 10. LUB means to calculate the LCM of 1, 2, 4, 5 and 10. And what is the LCM of 1, 2, 4, 5 and 10? It is 20. Similarly, what is the GLB of 1, 2, 4, 5 and 10? The GLB means we need to calculate the HCF of 1, 2, 4, 5 and 10. And the HCF is 1. Right? So without calculating the POSET, without calculating the Hayes diagram, using the definitions in the previous table, we can calculate the LUB and the GLB of any particular subset. Right? So you can try this exercise also. So here the POSET is 1, 3, 5, 7, 15, 21, 35, 105. This is a POSET on the set of integers. So this is a subset on a set of integers. And you need to calculate the LUB of 3 and 7. So that means you need to calculate the LCM of 3 and 7. You need to calculate LUB of 3 and 5, GLB of 15 and 35. And you need to calculate the least element, right? So least element means that you have to calculate the minimum element, right? So the answer, you can try this exercise and you can let me know in the comment section. So the answers are already given here. And thank you so much. So in my next video, I'll talk about Lattice. And subscribe my channel MathsHub so that you can get the latest video update, and do comment and like the video if you like it, and believe in yourself and you can always succeed. Thank you so much.